Good day everyone! So for today's video, I am going to report about the 3 mathematicians that I choose. But before I proceed to my report, let me introduce myself first. I am Queen Samantha, RAMA BSED 1, major in Filipino, batch 2. So let's further ado, let's start now. The first mathematician that I choose is von Neumann and Oscar Morgenstern, published Theory of Games and Economic Behavior on 1944. So now I am going to report about these mathematicians. But before I continue to my report, I would like you to know who's that mathematician. So first, let's introduce von Neumann. So this is the first mathematician that I choose, von Neumann. And this is Oscar Morgenstern. Yeah. So, game theory. It is originally developed by the Hungarian-born American mathematician John von Neumann. And his Princeton University colleague is Oscar Morgenstern, a German-born American economist. So Neumann and Morgenstern, they asserted that the mathematics developed for the physical sciences which describes the workings of a disinterested nature. So, they observe also that economics is much like a game, where players anticipate each other's moves and therefore requires a new kind of mathematics, which they call a game theory. Also, a game theory has been used to analyze parlor games, and its applications are much broader. In fact, game theory was originally developed by the Hungarian, who born in American mathematician. So guys, a game theory, it has been applied to a wide variety of situations in which the choices of players interact to affect the outcome. So aside from that, stressing the strategic aspects controlled by the players rather than by pure chance, that the theory both supplements and goes beyond the classical theory of probability. So a game theory also is generally does not share the fun or frivolity associated with games. So in addition about the game theory, those mathematicians, they observe that economics is much like a game, wherein players anticipate each other's moves, and therefore, they requires a new kind of mathematics, which they call a game theory. So, it has been applied also to a wide variety of situations, in which the choices of players, they interact to affect the outcome. So, expressing the strategic aspects controlled by the players rather than by pure chance. So, the theory both supplements and goes beyond the classical theory of probability. So, a game theory generally does not share the fun or frivolity associated with games. We have the classification of games. So, I'm going to post it. Okay. So, games can be classified according to certain significant features. So, the most obvious of which is the number of players. So, thus a game can be designated a one person, two person, or n person, or it is called also with and greater than 2. So with games in each category having their own distinctive features. So in addition, a player need not be an individual. It may be a nation, a corporation, or a team comprising many people with shared interests. So the extent to which the goals of the players coincide or conflicts is another basis for classifying games. So constant sum games are games of total conflict, which are also called games of pure competition. So the example of this one is poker. It is a constant sum because the combined wealth of the players remains constant, though its distribution shifts is the course of play. So another idea about the classification of the games, the extent to which the goals of the players coincide or conflicts is another basis for classifying games. So constant sum games are games of total conflict, which are also called games of pure competition. So one of the example of this is poker. So it is a constant sum because the combined wealth of the players remains constant, though its distribution shifts in the course of a play. So in variable sum games also, they may all be winners or losers. So the example of this is the two parties certainly interest, but both will benefit is a strike inverted. So the second mathematician that I choose is Abraham de Moivre. So Abraham de Moivre connects trigonometric functions and complex number. So I'm going to show you who's this mathematician. Ta-da! This is Moivre. So I'm going to explain all about the Abraham de Moivre. So Abraham de Moivre, born on May 26, 1667, he was a mathematician who was a pioneer in the development of analytic trigonometry and in the theory of probability. So a French Huguenot, de Moivre, was jailed as a Protestant upon the revocation of the Edict of Nantes in 1685. When he released shortly thereafter, he fled to England. So in London, he became a close friend of Sir Isaac Newton, and the astronomer Edmond Halley de Moivre was elected to the Royal Society of London in 1687, and later to the Berlin and Paris Academies. So another about de Moivre, he expanded his paper called De Mensura Sortis, written in 1711, which appeared in Philosophical Transactions into the Doctrine of Chances in 1718. Although the modern theory of probability had begun with the unpublished correspondence in 1654. So between Blaise Pascal and Pierre T. Fermat and the Treatise de Rationis in Lodo Alia on 1657 on ratiocination in dice games. So another about the Abraham de Moivre, he has the second important probability, so which was Miscellanea Analytica on 1730. So it is also called Analytical Miscellany. So Abraham de Moivre, he was the first to use the probability integral, in which the integrand is the exponential of a negative quadratic. So another idea that I can share about Abraham de Moivre, he originated Stirling's formula and correctly attributed to James Stirling on 1692-1770 of England, which states that for a large number of n equals. Stop. So, Abraham de Moivre, so probability of a compound event. So, it is composed of the intersection of a statistical and dependent event. It is the product of the probabilities of its components was first stated de Moivre's doctrine. So, Abraham de Moivre used Stirling's formula to derive the normal frequency curve as an approximation of the binomial law. So, was one of the first mathematicians to use complex numbers in trigonometric formula known by his name. So it is instrumental in bringing trigonometry out of the realm of geometry and into that of analysis. So that's all I can say about Abraham de Moivre. So the third mathematician that I choose is Veith. So here. So this mathematician invented the analytic geometry. So, okay, let me fix. Sorry. So the invention of analytic geometry was next to the differential and integral calculus, the most important mathematical development of the 17th century. So, we have the two tendencies in contemporary. So the first was an increased interest in curves, resulting in part from the recovery and Latin translation of the classical of Apollonius. So the second one was the emergence of century earlier of an established algebraic practice in the work of the Italian and German algebraists and its subsequent shaping by Veith into a powerful mathematical tool at the end of the century. So another idea about Veith. So Veith introduced the concept of algebraic variable, which is here denoted using capital vowel like A, I, O, as well as the concept of parameter denoted by a capital consonant B, C, D, and so on. So in his system, the equation 5BA2 minus 2CA plus A3 equals D would appear as B5 in A equals minus C plus 2 in A plus A cubs equator D solido. So, another is the analytic geometry. So, it is the next to a differential and integral calculus. So, that should be all that I can give you the idea of about Veith. So, I hope you learned about my reporting about the three mathematicians that I choose. So, have a nice day to all. Thank you for watching for my videos. God bless. Mwah.